Hello everyone and welcome to my hints video for your take-home exam that you have been working diligently on since you left for break back on, well, most of you on December 22nd. Please keep in mind that we do have, this is the take-home portion, you do have an in-class portion that will be taken on Tuesday for everybody, and then those two will combine to be your exam grade. That will also complete the whole semester exam for you. You won't have any exam per se on the scheduled exam period. That will be a normal class, whatever happens to fall during that time. Also, one of the other things I hope you noticed is that on the take-home exam, the multiple choice questions, those are all non-calculator questions. So while some of you may have pulled out your calculator at times, the calculator should be avoided as much as possible when working on those. If you are working or talking to somebody as you're working on these things, make sure that anybody that you are talking to, working with, that everybody understands exactly what is done on that problem. And make sure for all the multiple choice that you can do those without a calculator. Another thing to keep in mind, there are some problems on the multiple choice. This was from 1988. The exam syllabus has changed a lot. There are some pre-calculus questions on this exam. Some basically dealing with log properties, some trig identities. But for the most part, those specific types of problems won't be there. Now, you might have to deal with those properties as you progress through on a problem, but it will not be directly tested on the exam. So with that, let's move to our hints. Now, as I went through and I was looking through this exam, I remember that there were some problems on here that could be kind of tricky. And we haven't necessarily covered the specifics about those, but you do have the tools to complete these particular problems. And one of those is problem 26, and it is also comparable to problem 17, which is something very similar where they're asking you to find the area between two curves. What you really want to do on this one is use your definition that we have for a definite integral. We know that a definite integral of a function is the area between the curve of the curve and the x-axis. So what you really want to do on this particular problem here is we're going to go and find, look at the curves as separate pieces. So we'll have this one right here, and our second curve is down here is g of x. And what I really want you to do in terms of working on this particular one is think of it in terms of a definite integral for those. Okay, if you're going to find, you want to find this, you're going to be looking to find this area and this area, and you want to put those together. Well, really what happens on this thing, look at it in terms of going from A to C in terms of the definite integrals of each one of those two functions, and that should help. You also have properties of integrals that you've worked with. We know that if I have the integral of a function f of x plus g of x dx, that is equal to the integral of f of x dx plus the integral of g of x dx. So use that information to kind of help you out with that one. But the main key on this is really look at this region that we have here as a definite integral involving two functions, f of x and g of x. One other thing, as I mentioned, this is very similar to what you have in problem 17. So one thing that could be helpful on that one is to make a graph. make a graph of those two functions, and see what you can do from the graph of using the same idea that I just I'm trying to explain on this one to solve that particular problem. Now we're into the free response. In terms of the questions that are there, I am going to go through and kind of say something about each one. The first one here, you're dealing with the velocity of a particle that's moving along the x-axis, and you're given the velocity function. So remember the relationship that you have between velocity and acceleration and position. That will be key on this particular problem. Another thing, remember the difference between velocity and speed. Velocity gives you direction. Speed does not. When we say a particle's speed was something, you don't know what way that it's traveling. But if I tell you a particle's speed is +7 or -12, that gives me some more specific information about how that particle it happens to be moving, or that object happens to be moving. So the first one really is this first part here is going to be pretty straightforward. Just remember to answer the why. On a problem like this one right here, each one of these on the AP exam, each one of these would probably be about 2 points. There'd be one of these problems would probably be worth 3 points. In terms of it, this one would be a 2-point problem. And in terms of identifying which direction it's moving and why you're saying that. Now the acceleration here at 1.5, they want to know is the velocity increasing at 1.5, why or why not? Now remember here, velocity tells you something other than just speed. Okay, it gives you direction. So as a hint on here, you will need to compare your answers for part A and part B in order to answer this particular question. Or at least how you got your answer, the information you had from part A, how you answer that question. Give the position of this particle from at y equal 2, given some information there. Again, remember when you're dealing with velocity, you have to remember what that since we're looking at position, we know it's the antiderivative, what that definite integral of the velocity function tells you. That is going to be key on this one, and that will come into play with this particular problem. And then the total distance here, again, think about how that has to happen. Remember when you go through and look at a problem like this, how you go and calculate a definite integral. If you graph this function, this particular velocity function out on the interval from 0 to 2, you will probably notice that there are portions of the graph above and below the x-axis. So you have to think about what the difference is between a definite integral and finding that total distance traveled, and how would you go about dealing with that. In question 2, we're dealing with water that's flowing out of a pipe, and you got in gallons per hour. And so, again, what they're telling you here is you got the time here in hours, and then you have the rate that the water's flowing out in gallons per hour. Now notice on this one that we are specifying that this is flowing out. The problem does have that, so you don't need to have the negative on there. But if this was dealing with something where water was going in or out, you would have to have the positive or negatives on those. That would tell us something. Now in this case here, this is a real common thing I've seen in the last few years in terms of the AP exam, that they will give you a problem like this where they tell you specifically, they want you to do a midpoint Riemann sum with 4 subintervals. So you're going to find the area of 4 rectangles to approximate this definite integral. Now you have to use a midpoint, but notice here what you're going to want to do. The first thing you're going to have to do on this is you're going to want to find delta x. Find delta x, and again, we talked about how you can go about doing that in the problem. And then once you know what delta x is, then you can really identify the intervals that you're working with, and then identify what those midpoints are going to be, and then find the areas of the 4 rectangles. Okay. Next thing, part B is looking at that. Really remember what they're asking for here on this problem is that they want to know, is there some time between 0 and 24 in that day when R prime, that the rate, that the derivative of the gallons per hour is equal to 0. On that one, and you have to justify your answer on this one. There's a lot of different ways you can justify that answer, and there's a lot of different ways you can approach this one, but you have to go through. They're all going to involve some sort of ways that you can approximate R prime. The other thing you have to do on this one is you would really have to recognize what R prime of t equal to 0, what that's going to mean for these values here. What in terms of what's happening on there. R is going to be a differentiable function, so that tells you that it is that every value from 0 to 24 there is a derivative, there is a value for R prime. It is not ever, it will never be undefined on that interval. In terms of part C, you're given a function that says q of t, which can be used to approximate r of t. And so they want you to find the average rate at which the water flows in that 24-hour period. That is something that we talked about once we started with the fundamental theorem of calculus. So you should find, if you don't recall how to find the average value, the average, like an average rate of change, or the average value of this function, use looking back in your book in terms of the last couple sections, in terms of the fundamental theorem of calculus, and you should see, in fact, I'm pretty sure that they will go through and say this is the average value. So you can find the formula that you're going to use there. Also on these things, as with problem 1, 2, and with what's coming up in 3, remember that your calculator is allowed there as well. You can use your calculator too. Actually, I think I did make a mistake and misspoke in a previous one. This one right here would definitely be a non-calculator question. I think maybe even 2 could really be done without a calculator, but I think that one would have a calculator available to it. This one right here, what you have is you're given a graph up above, and they tell you that this graph here is a graph of the function f. In other words, and it's one thing that's always good to do, is it's always good to sit there and say, just make sure you highlight the fact that this graph is y equals f of x. That's what it represents. And what they want you to do on this one, you also want to go and recognize, based on what they have here, they're telling you g of x is equal to this. What is the relationship between g and f? That will always be something you'll want to keep in mind. Now in this case, you have to go and compute g of 4 and g of negative 2 using this definition right here. They haven't told you anything about a specific, the value of g at a specific location, so you don't have to worry too much about that. But please remember to go through and calculate those. And again, remembering how when you plug that in here, how you would go through and calculate each one of those definite integrals. Finding the instantaneous rate of change of g with respect to x at x equals 1. That really, again, is recognizing what I mentioned before, the relationship between g and f. Find the absolute minimum on that interval from negative 2 to 4 for g on the closed interval. So we do know, in this case, we do know the values since it's a closed interval, we do know that we will have an absolute max and an absolute min. Also notice here, it is not an accident that they're asking for this interval when you think about what you were asked to find up above in part A. And then the last part talks about the second derivative and using that information to go through and determining points of inflection. In terms of these, one thing that can be helpful, I think, on this one, because this particular graph of f is made up of linear pieces, you do know the endpoints of those functions, of those particular pieces, you are able to calculate some slopes. So that could help you in terms of answering part D. Now I want to get to some of the questions that have been sent to me so far. In terms of these, if any others come in, I will answer some additional questions with them. But for the most part right now, what I'm looking at are 15, 18, 27, 28, 31, and 35. 17 was asked about, and that's one that, again, was similar to problem 26. So you won't see much. You won't see much with that one. I've already kind of discussed that one. In terms of problem 15, you're asked to go through on that one and they want you to find the second derivative of this particular function. Okay. Not sure what the question was with this one, except for the fact that you do need to be aware of the chain rule as you go through with this one. Keep in mind, you don't need to do a product rule on this one. I wouldn't, because you can just use the fact that the derivative of a constant times a function is equal to the constant times the derivative of that function. So you can just work with that from there. Problem number 18. Problem number 18 is and N27. Both are really pre-calculus questions. In terms of 18, you're using the log properties that we know and love to go and tie these two together into a single log, and then solving the log equation at that point like we did last year. You might want to recall on this one that when we worked with these last year, we had a definition that we used for a log that said that y equals log base b of x if and only if b to the y was equal to x. In other words, that's what we use to write a log in its as an exponential. And that's really what you're going to end up having to do with this one. 27 is really just a trig identity. You can find those if you look inside your front cover of your textbook. You'll have the table of derivatives and integrals, and if you turn to the back of that, you will find the different trig identities, and you're just using one of those identities to go and simplify that. Now you will need to know the unit circle top to bottom. Okay, so when you're working on those ones. 28 is an average value function. It is something related to what we just talked about for the free response, problem number 3, it was problem number 2, part C. That was an average value, and this one is also an average value. So that's going to be at one of the last, when we were in the section dealing with the fundamental theorem of calculus from your textbook that we covered just, in the last few days before break. Problem 31. Problem 31, you're given a diagram and you're told some information. And really that diagram has 3 lengths labeled, x, y, and z. X and y, yes, happen to be the sides of a rectangle. Z happens to be the diagonal of a rectangle. And so for problem 31, you want to use the fact that x squared plus y squared equals z squared. That gets you a relationship They tell you what x and y are. They want you to find dx dt when x and y happen to be equal to 3 and 4. What you're going to need to do is start out with this relationship here between x, y, and z. And as we talked about, when you deal with related rate problems, take the derivative with respect to time. And then you can try to simplify that as much as you want. But then once you have that derivative, then start plugging in the different pieces that you know. Use the given information, like they tell you what dz dt is equal to. They tell you a relationship between dx dt and dy dt that we can use to go and solve that problem. And they happen to tell you they want to know what is happening when x is 4, y is 3. That should sound familiar to you. Z happens to be the hypotenuse of that triangle that they're talking about there. And one leg is 3, the other is 4. That probably is pretty familiar to you in terms of what the value of z is. But you plug all that information into the derivative of this, and then you're able to go through and find the information you need to do to end up answering the final question, what is dx dt? Number 35. Number 35 is an optimization problem. They want you to minimize the amount of tin that you have. Now, what you're told in here is that the volume here of the can, the volume, oops, let me make that into a pen. The volume is equal to 16 pi. That's the volume of that can. They want you to minimize the surface area, if you will. Now, with that can, you got the sides, and then you have the two circular tops. Now, if you take a look at, in terms of in the back cover of your book, there's formulas from geometry. They deal with like a right circular, the different shapes. You got to keep in mind what's forming this can. And also use the whole idea that the volume of that cylinder happens to be pi r squared h, so that you can identify relationships so that you can answer this particular question. Okay, so I know that pi r squared h equals 16 pi, and then you're going to have to minimize surface area, and surface area in this case is going to be the surface area of the cone of the side of the cylinder, plus the surface areas in the top and bottom of those cylinders. So you got to use all that information in terms of answering that question. So to this point, those are the questions I have. I hope that these were at least somewhat helpful to you. I'm sorry if I'm not being as clear or as forthcoming with information as I possibly can, but I want you to go through and be aware of the different, do your research on it and solve these things. Again, make sure if you are talking to anybody, or if you're working together on these, that everybody that you're working with has an understanding of every single one of these problems. That will be necessary. And so I will, at this point, these are the problems that people have sent me questions on. If I do happen to get any others, I will probably just do those via the chat on Remind. If I see them. Otherwise, you can come and ask me some questions if you want during SRT on Monday. That would be a possibility as well. But with that, again, I hope you have had a good break and that you are progressing with everything. And I'm looking forward to getting started back up with this and beelining it for the AP exam. My goal is still, at this point in time, is to complete the AP curriculum before the end of the third marking period, and then we will take the exam. Remember, we'll take the exam after spring break. That will be your exam for my class for the second semester. That will be during spring break, and that will actually be over multiple days and will be an AP exam. Will be not a released one, it'll be a secured sample of an AP exam. So with that, I look forward to seeing you on Tuesday, Monday if you have questions, and enjoy the last couple of days. See you later.